Every time you interact with an Android application, the screen in front of you is a highly volatile system. This diagram maps the core structural phases of that system into 6 distinct states: loading, success, error, empty, answered, and finished. A typical user session shifts rapidly among these specific conditions as data is requested, processed, and displayed. The stability of an entire mobile application depends on how rigidly the underlying architecture defines the boundaries between those conditions. When an architecture fails to draw clear lines around each state, the interface layer has to bridge the gap with its own logic, which quickly becomes convoluted. That convoluted logic generates an exponential increase in unpredictable rendering bugs, like screens completely freezing, data duplicating itself, or buttons becoming unresponsive. To prevent these structural failures, state management cannot be treated as an afterthought. It must act as an uncompromising architectural constraint. The standard approach developers use early in a project is known as implicit state. This diagram shows how implicit state tracks the application's status. Developers assign 6 independent Boolean flags, essentially true or false switches. Because each isolated variable flips its own switch, it has no awareness of what the other 5 flags are doing. We define an unclear state as any condition where our system loses holistic oversight of these isolated variables. Without a central authority managing the total picture, the rendering layer is forced to inspect multiple disconnected flags and guess what the application actually wants to show. Implicit architecture shifts the burden of logic out of the structured data layer and onto the fragile interface layer. The complexity of this approach is a direct result of how these independent variables scale. 6 independent true or false variables generate 64 distinct configurations. Exactly 6 map to intended states. The rest represent invalid intersections. If a network request finishes but loading remains on, the system registers as loading and finished simultaneously. To prevent the application from crashing when it hits one of these contradictions, the code must account for all 58 invalid intersections. Developers typically react to this by writing deep, cascading conditional if-else checks, trying to manually force logical order onto the chaos. This geometric escalation of required conditional checks is known as cyclomatic complexity. Adding independent variables to track an application's status expands the bug surface area rather than clarifying it. The methodological antidote to runaway cyclomatic complexity is explicit state modeling. This model collapses the truth table by enforcing a single rule: states are mutually exclusive entities. By existing in only one node, snapping instantly from loading to success, the architecture mechanically eliminates 58 invalid overlapping states. Contradictory UI commands are rejected before the application even runs. No more defensive conditional logic guarding against impossible system scenarios. We replace 64 chaotic combinations with exactly 6 deterministic operating modes. Explicit state transforms UI rendering from a guessing game into a deterministic pipeline. Creating isolated nodes solves the overlap problem, but managing state also requires strict control of the pathways between those nodes. This diagram outlines how explicit architecture strictly dictates permitted pathways. A valid transition, like moving from loading to success, smoothly executes. But if logic attempts an invalid transition, like jumping from error directly to success, the architecture blocks it. Recovering from an error state physically forces the logic to transition back through a loading or verification phase. This forced routing mechanically guarantees that data integrity is restored before rendering the final UI. Controlling transitions isolates failures, ensuring that a logic bug in one state cannot silently slip through and corrupt the following state. Looking at the practical codebase results, the contrast between the two architectural philosophies is stark. Implicit state results in massive, unreadable conditional blocks that are difficult to test comprehensively. Explicit state results in a streamlined, single-path routing statement mapping exactly to the 6 core states. Clear UI state management is an exercise in establishing uncompromising system constraints. Loading, success, error, empty, answered, and finished serve as the absolute boundaries of the interface. Adhering to these structural boundaries systemically reduces rendering bugs at the root level. The elevation of overall application stability relies on this rigid architecture. By moving from reactive guessing to deterministic modeling, the developer ensures that the UI remains a predictable reflection of the application logic.